Welcome to the deep dive. Today we're looking at something seemingly small, but actually critical. The electrical connector. You know, that final gatekeeper of power in so many high-performance systems.
Absolutely.
And we're diving into a really key question. What is the actual difference between, say, a genuine W.S. Dean's Ultra Plug and all those T-Plug clones you see everywhere?
Right. And let's be clear, this isn't just about branding. It's not just a name.
No.
We're talking about fundamental engineering differences. Material science, quality control, and ultimately safety.
Big differences, like potentially a 70% jump in resistance. That's huge.
Exactly. Our mission today, uncover what these differences really mean for performance, for reliability, the things that matter when you plug something in.
Okay, so let's start with the benchmark, the genuine article, the Dean's Ultra Plug. Tell us about W.S. Dean's Co.
Well, W.S. Dean's goes way back, founded in 1955 by an aerospace engineer, actually.
Aerospace, okay, that says something.
It really does. Their whole philosophy is performance comes first. And they've been manufacturing right here, made in the USA, since the 50s. That's why you see them in really demanding fields. Military, aerospace.
Places where failure just isn't an option.
Precisely.
So what's the core engineering behind that trust? What makes it tick?
It's quite elegant, really. It relies on sprung, flat metal tabs. Think of them like tiny internal leaf springs.
Okay.
This design achieves two crucial things: a large contact surface area and really consistent high pressure between the contacts.
And the pressure means low resistance, right?
Exactly. Low resistance and durability over many connection cycles. But, and this is key, this design only works if the materials have very specific properties. Get the material wrong and the whole thing falls apart.
Right, that reliance on specific materials sounds like where the clones might cut corners.
That's often where the problems begin. Let's talk materials.
Okay, let's get tangible. The housing, for instance. Genuine Dean's use a high-temperature, glass-filled nylon 66.
Tough stuff.
Yeah, it doesn't just resist heat like from soldering, but those glass fibers give it real rigidity. It won't easily deform. Clones, though.
Clones often go for, well, cheaper commodity plastics. Things with a low melt point.
So they deform easily under soldering heat.
Exactly. They melt, they warp, and suddenly those precisely aligned contacts aren't aligned anymore.
That's a big problem right there. What about the contacts themselves, the metal parts?
Another huge difference, genuine Dean's use a proper spring alloy, often something like beryllium copper. It holds its tension. Plus, it has industrial-grade gold plating, thick, durable,
When the clone.
usually soft brass. It bends easily and loses tension quickly, meaning contact pressure drops off. And the plating, it's typically just a cosmetic flash gold plating. It's super thin.
So it wears off easily.
Very quickly, you get maybe a few connection cycles before it's gone, and then resistance starts creeping up fast as the base metal oxidizes.
Okay, so these material choices directly impact electrical performance. You mentioned resistance earlier. Let's unpack that. The resistance is basically the enemy, yeah.
It's the root of all performance. And sometimes evil. Ohm's law, power loss formulas. They all tell us higher resistance equals voltage drop under load and wasted energy as heat.
And you actually feel that difference in an RC car or a drone.
Oh, absolutely. The numbers are stark. A genuine Dean's plug aims for around 0.10 millions. That's incredibly low.
Only 1-0.
Clones, we often measure them around 0.17 millions, sometimes higher.
Wait, that's a 70% increase.
Exactly. That extra resistance literally starves the system of power. Your RC car is slower. Your drone does struggle for lift. It's like trying to run a marathon breathing through a coffee stirrer.
Wow. And amperage. How do they compare there?
Genuine Dean's are rated and reliably used for 60 amps continuous, 75 amps burst. People push them past 100 amps often.
And clones often say 50 amps on the packet.
Right, but because their actual resistance is so much higher, they generate way more heat at that current. They often fail at or even below their marketed rating. They just overheat.
Which leads us to the consequences, the real-world risks.
And they are serious. We're not just talking poor performance. We see thermal melting, like we discussed, during soldering or heavy use.
Right.
We see mechanical failure, the contacts losing tension, leading to intermittent connections. Imagine that happening in an RC plane.
Loss of control. A crash.
Definitely. And the worst case, catastrophic short circuits if things melt and shift internally. That can mean sparks, fire, even destroying expensive batteries.
Sounds like a cascade effect. Really. Cheap materials,
Lead to deformation,
which causes misalignment,
leading to poor contact, high resistance.
and boom, system failure. They're just fundamentally unreliable.
Fundamentally.
So how can people protect themselves? How do you spot a fake?
Okay, first, branding. Genuine ones say Ultra Plug. If it just says T-Plug or has no branding, be wary.
Any visual tells.
A key one is often the male pins. On a genuine Dean's, the curve on the flat pin is smooth, continuous, like a gentle arc.
Mm-hmm.
Many fakes have a noticeable crease or a sharp, angular bend right in the middle of that pin. It's a sign of cheaper manufacturing.
Good tip. And where should people buy them?
Always go to authorized dealers or direct from reputable suppliers. Avoid the big, unvetted marketplaces like Amazon, eBay, Temu for critical parts like this.
Because the price difference can be tempting.
Exactly. But if a price looks too good to be true, it probably is. Quality materials and manufacturing cost money. A significantly lower price is a massive red flag.
It's also fair to say the connector world hasn't stood still, right? There are other options now.
Oh, absolutely. Connectors like the XT series, XT60, XT90 developed by Amass, or the EC series like EC3 and EC5 are very popular.
And they have some advantages.
They do. Often easier soldering with their cup terminals, and they're typically fully shrouded, meaning the metal contacts are recessed in the plastic. That adds a layer of safety against accidental shorts.
But the same rule applies. Surely.
Yeah,
We need genuine ones.
Crucially, yes. Clones exist for XT and EC connectors too, with all the same material and performance issues. You must source genuine Amass XT connectors or genuine EC connectors from reputable places. The brand matters, but the authenticity matters just as much.
So buying cheap is just.
It's a false economy, especially in high-power systems where failure can be costly or dangerous. Saving $1 or $2 on a connector just isn't worth the risk.
A really important point. It leaves us with a final thought, doesn't it? If this tiny, often overlooked component hides such critical differences, what other invisible parts in the tech we use every day might have similar issues? How can we take this lesson about quality, materials, and reliability and apply it more broadly to ensure safety and performance everywhere? Something to think about.